So for this very first problem, we're going to go for twosome. It's a classic in interview questions, and we're going to read the statements together. So given an array of integers nums and an integer target, we need to return the indices of the two numbers such that when they are addition together, they add up to the target. So there is only exactly one solution, and we cannot use the same element of the array twice. A note is that the array is not considered to be sorted, and everything we are dealing with today are integers. So how can we approach such a problem? First, let's make some examples of what we need to do. So we have the first example, which is an array constituted of 2, 7, 11, and 15. And that array has a target that is linked to it, and the target is 9. So the target is 9. So we need to find the two integers in that array such that when they are added together, they will reach 9. So we can naturally iterate over it in our head. So is 2 plus 7 adding to 9? Yes. So that was quite easy. What we need to return here is 0, which is the index of the element 2, and 1, which is the index of the element 7. So that's the first example. A second example, to make sure that we understand, we have an array 3, 2, and 4. So as you can see, unsorted. And we need somehow to reach the target 6. So how can we do that? We try to add 3 and 2 together, it yields 5, that's not it. Then 3 and 4, 7, that's still not it. Then 2 and 4, 6, that's it. So see, what we do naturally is that we iterate over that array, and then we compare elements 2 by 2 in an exhaustive manner to be sure that we do not skip the right answer. And we need to implement an algorithm that does that. So let's see together conceptually how we can implement such an algorithm. We can use the first example again with the 2, 7, 11, and 15. I'm just going to change the target so that it's not as easy to reach it. So the target, let's say, is going to be 7 and 11, so 18. Okay. So we have the brute force approach, which would be an algorithm that would simply start at this index here with the 2 and exhaustively iterate over the array in such a manner. It would start a pointer at 2 and another pointer one position to the right. And it would do the addition and say, oh, did I reach the target? Here it would be 9, so I did not reach the target. Then it would try the next element, and it would also realize, just a second, there you go, it would also realize that, oh, 2 and 11, that's 13, is it equal to 18? Not really, therefore I must try the next possibility. At the end of the array, it would then shift the left pointer of one position, and it would keep doing that. That is not optimized, because the time complexity of this algorithm would be O of n squared. O of n squared. Why? Because we do one first pass with n computations, n minus 1 actually. Then we do a second pass with n minus 2 computations. Then we do another pass with n minus 3 computations. And until we reach the target. And in the worst case scenario, we would do that until there are only 2 elements left in the array, and that would finally be the answer. So how can we optimize that? We can simply use a data structure that is very useful in this kind of situation, which is a hash map. Why is a hash map useful? Because a hash map has a time complexity to write into it or access it O of 1. it's virtually free in terms of time to use a hash map. So what we can do with the hash map is quite interesting. It's a little trick. We would iterate with only one pointer that will begin here. We would set up the hash map. Let's call it H. There you go. So set up your hash map, and then you will simply add this element at some point during your algorithm. So what you want to calculate first is you calculate the difference between the current element you are iterating over and the target. So here it will be 18 minus 2, so the difference, called D, is 16. Then you would look into your hash map and see if you have a 16. If not, that means that you never encountered the 16 before, and you are still looking for the other half of the addition that would yield the target. So here we don't have a 16. So what we do is that we keep in mind we encountered the 2, and we also keep in mind that we encountered it at index 0. And then we shift. That way, when we finally find something that will, when added with one of the elements of our hash map, add to the target, we will know. So let's implement that. Alright, so now we can implement the code that we talked about. The first step of that is going to be initializing the hash map that will store pair of the value that we encountered and its index. Okay, so how do we do that? We simply will initialize a variable called encountered, and this is going to be what we call a default dictionary. It's a hash map in Python with a default value. So default dict with, we're thinking to use an index here, so it's going to be an integer. We need to import it. Just like so. And what's gonna be good to do after that is probably iterate over the array. So for let's say value and index, no, that's the opposite actually. Index and value in enumerate. So enumerate, that's why I just swapped them, because enumerate works in a very specific way. It will return like a 0 value 1, okay, and then 1 value 2, all right, and you need to keep track of that. So what we want then is to calculate the difference between the value that we are currently considering and the target. So initialize another variable, diff, that is target minus v, all right, as simple as that. And then you just check if in your hash map or dictionary called encountered, you have this diff as a key. So if diff in encountered should do the trick. It will check all of the keys. And if you have it, then congratulations, we have found a solution and you just need to return it. It's going to be the index of the current value and the index of the value that was stored. So remember, the index here is the value and the value is the key. That's a bit confusing, but that's the case. All right, that should do the trick. If that was not successful, then we add the value and the index to our dictionary. So encountered of the current value v is equal to I. And hopefully that computes. Let's see. No, it doesn't. Why? Import collection. Ah, that's as simple as that. Still no. Let me see how to fix that. From collection, import collections, probably, right? There you go. It was as simple as that. All right, so that's it for that problem. So it's a classic. We have to learn it in order to prepare for the interviews, and hopefully you found it useful.